Today we are going to start the functions of the bounded variation, the content from the Lebesgue measure theory. So the definition: let f be a real valued function defined on the interval, the closed interval ab, and let a equal to, let's say, x naught and is less than x1 and is less than x2 up to so on be any subdivision of the closed interval ab. Right? So taking x naught to be as a and xk to be b. The endpoints are a and b for the closed interval ab. It is the subdivision of closed interval ab. And then we define small p to be the summation on fxi minus fxi minus 1, that is the positive variation. Positive variation means we are identifying the segments where the function is increasing, right? And sum their positive variations to the total function change. And let's take n to be the summation on f of xi minus f of xi minus 1, that is the negative variations. Negative variations means to identify the segments where the function is decreasing, right? And sum their absolute negative variations to the function's total change, right? Where r plus denotes what? R if r is strictly greater than 0, and is 0 if r is less than equal to 0, right? We take r minus to be equal to the absolute value of r minus r plus, right? Okay. Then we denote t to be the sum of positive plus negative variations. And we take this to be equal to the summation on the absolute value of f of xi minus f of xi minus 1 mod, where I is starting from 1 to k. And then we define p minus n to be, that is the difference of the positive and negative variations, and is equal to the summation on f of xi minus f of xi minus 1, where I starts from 1 to k. It is the overall function change. It should be equal to the total function change over the interval ab, the closed interval ab, right? How this could be? So this is equal to, when we sum up all these, we get f of x, the higher value for I, that is k, minus f of x, the lower value of I, that is 1 minus 1, which is 0. So this is 0. So this is equal to, what is xk? It is b. We have taken xk to be b and x0 to be a. So minus f of x0, that is a. So their difference is fb minus fa, that is the total change in function over the interval ab. Let's take capital P to be the supremum value of small p, that is equal to supremum of, what is small p? It is the summation I going from 1 to k on f of xi minus f of xi minus 1, and is the positive variation. Because it is a positive variation, we write plus at the top. And then capital N is taken to be the supremum of small n, that is equal to the supremum value of taking the summation on f of xi minus f of xi minus 1, that is for the negative variations. And capital T is the supremum of small t. Please remember, whenever you write the value for the small t, the summation is on the mod of f of xi minus f of xi minus 1. That's it, right? Here we don't have the mod, but please remember, for small t you have to take the mod, the absolute value of the change in function. Let's move further. Now this supremum is taken over all the subdivisions, all the possible subdivisions of closed interval ab, right? Please remember this. So we say this capital P to be equal to the positive variation of f over closed interval AB, and capital N to be the negative variation of f over closed interval AB, and capital T to be the total variation of f over closed interval AB. Very fine. Okay. And we sometimes write the another way to express these, that is P and writing here AB, the positive variations of f over closed interval AB, capital P, or you can also write this as the positive variation of f over closed interval AB. Similarly, writing the negative variation, capital N AB, or you can also write this as capital N, the negative variation of f over closed interval AB, and TAB, or the total variation of f over the closed interval AB, in place of P and T, right, to denote the dependence on the interval, closed interval AB, or on the function, right. It denotes the dependence on the function and also on the closed interval AB. Now if this capital T, the total variation of f, is finite, we say that f is bounded variation over closed interval AB, and we can also write sometimes f belonging to the BV, that is the bounded variation. We can also sometimes write like this, f belongs to BV means f is bounded variation, right. Now again since we know that we can write small p to be less than equal to the sum of n and p. Can we write like this? Yes. And is equal to, what is sum of n and p? It is small t, and small t is less than equal to capital T, because capital T is what? It is the supremum of small t. So capital T is greater than equal to small t, which means what we are saying that therefore small p is less than equal to capital T. And if I take the supremum over all the possible subdivisions of closed interval AB, what we get? If I take the supremum over all the possible subdivisions of AB, then this small p will be changed into the capital P. So the capital P is less than equal to T now. So we get capital P to be less than equal to small t. Similarly, we can also get capital N to be less than equal to small t, right? And again, since what is small t? It is the sum of n and p, right? And because the small n is less than equal to capital N, plus the small p is also less than equal to capital P, we write t to be less than equal to capital N plus p. And if I take the supremum over all possible subdivisions of closed interval AB, what will I get? The small t will be changed into the capital T. So capital T is always less than equal to the sum of capital N and P, right? So these relations are very important. Please remember all these. So next time we are going to do some lemmas on these functions of bounded variations, right? Okay, thank you.